So here's our lovely Gurley meter, Price AA. So first thing I'm going to do is check the meter, make sure it's all hunky-dory. The meter serial number corresponds with the calibration card, and everything is still within specifications for the calibration date. So the Price AA meters have got a locking nut down this bottom here, which stops the buckets from riding on the pivot when it's travelling in its box. So we undo that, and the buckets will spin freely. That locks around, and then that's locked in place, and the weights are there to sit at the bottom, so the fin will be in position like that. So just doing the spin test, usually put the fin together so that when I do my spin test and somewhere where it's out of the wind, I can sit in the back of the truck like that, for example. It'll sit nicely on its fin, and I can spin it and it will run for its total time. The minimum spin test is 160 seconds free spinning, so it should spin for more than 150 seconds. And just a flick or a blow will do it. So also in my gauging box, you'll find some spare parts. Importantly, there are some spare pivots. Now these are what the bucket rides on. There's a flat surface here, which when that pivot is inserted in the bottom of the meter, there's a screw on the side, and that aligns with the flat piece of that pivot. And so if it doesn't meet the spin test of more than 160 seconds, I can usually, the pivot's worn down, I can try one of these other pivots, or put a little bit of lubrication oil on them, and that may help my spin test. Alright, that's just about there, so we'll stop it there. So that's 4 minutes and 20 seconds, so that's well in. Just filling out the gauging card here. What I'm writing down is the meter slope and constant calibration factors, so that when we come to calculate this later in the office, we have that information already at hand. So the slope here for this particular meter is 0.675 plus a constant of 0.008. And assemble this on our weighting rod. Make sure it's all nice and tight. And again, with the fin aligned upright with the weights of the fin at the bottom. That's the physical meter. And then we've got the electrics, the wiring to be assembled. There's one wire up top where the reed switch goes, so every time that bucket turns one revolution, the magnet on the shaft closes a reed switch contact, and that creates our pulse. So there's one positive wire, one earth wire on the body of the meter, like so. Make sure the wires are out of the way of the bucket. We attach that to our current meter counter. We'll do a 40-second period count here for this gauging. We get some counts. Okay, and that seems to be working fine, so we're ready to go and gauge. So in position to start my gauging here. Quite luckily the staff gauge is just in front of me here, and I can read what the staff gauge is as I start. So my tag line's set up. I know that's 8 meters across approximately, and I'm going to want to split that up and do about 25 verticals. And looking at the flow, it's seems reasonably nice and laminar, so I'll probably just split it up into even verticals as it gets a bit deeper out to the edge. We might start with doing 0.6s in the close edge here, and then as we get a bit deeper where it's a bit faster, I'm sort of suspecting it's not going to be laminar flow anymore, so we might start doing 2s and 8s measurement points. So at our starting edge, I'm going to write down what the distance across is here. At depth 0, that's our starting edge, 1.7, and our depth is 0, and that is our water's edge left bank, and that will be an assessment point. So commonly when you're starting your gauging, sometimes it's very difficult to get the edge measurements, usually because maybe there's very little flow there or there's grass on the banks. What we can do is write down, if we can get a depth measurement, that's useful information because it helps add to our profile. So we can record the depth and record it as a sounding with no velocity measurement. If it's not possible to do that either, we can put it in as an assessment and give it a percentage, so that there is some flow attributed to those segments at the edge. So in the case of the first observation we made there, we will put in an assessment of 50% at that edge. So that's our starting edge at that point, and we're going to come out to a distance where we can do our first measurement. There's a bit of grass down there, so maybe somewhere there seems reasonable, so that's at 1.95. And that's a depth of there. So because this is a traditional wading rod rather than a top setting rod, we have to remember where we've positioned it and read it off the increments on this wading rod for our depth. So that was, these are centimetre increments, so we've got double marks are 10 centimetres apart, so 10, 20, 30, 35 is the water depth, and I'm going to want to set that at 0.6 of that depth. So when we're doing our 0.6 point velocity measurements, that is at 40% of the depth, so it's 0.4 up from the bottom, or if you're measuring from the water surface down, as you would do with a cable suspender gauging, it would be 0.6 down from the top. But because we're doing a wading gauging, we're going to be setting our meter at 0.4 up from the bottom. The easiest way to figure out a 0.4 is to take your water depth, double it again, and then divide it by 10 as a quick rule of thumb. So let's say it's the depth we measured there was 0.35. So if we double it, it's 0.7, double it again, it's 0.14, and divided by 10. So we want to set that at 14 centimetres. Now we position our meter at 14 centimetres there. The middle of the meter is at the mark we want to set it at. And pop it back in position. Push start. So we've got our first measurement there. We're going to move out to another 20 centimetres. So now we're at 2.2. So we're 2.2 across on our tag line, and our depth is, so no, that's 50, 60, 70, 80. Just be aware that sometimes where there's a reasonable flow, you get a bow wave in the front sometimes, and a bit of a dip behind. Sometimes you'll get a meniscus forming on the staff as well. So It's easy if you get down close to water level if you can, and make sure you make a good assessment of what you think the water level is. So 0.78. So 2.2 across, a depth is 0.78, and we'll do another 0.6 there. So if we double 0.78, double it again, divide by 10, you'll get your 0.4 setting for your meter. Move your meter to the observation position. "40 seconds is up, and the counter has recorded 17 revolutions at a time of 41.2 seconds. And then we move on to our next segment. So I'm going to continue on like this until I get a little bit deeper. I'll probably do every 0.3 segment across until I get to maybe up to about let's say 0.9 of a meter deep, and then I'm going to start doing 2s and 8s. I've moved across another 0.3 from my last measurement to the next segment. I'm at 2.5 meters across, 0.79 is our depth. While it's counting, I'm sort of watching that there's no debris coming down. I'm listening to the meter counts. I can hear it's nice and constant, which means I'm confident there's no debris wrapping up in that propeller, even though I can't see it. And I'm standing well enough, you know, almost an arm's length back from the meter, so I know that my body position is not influencing the velocity. And there we go, that's counted 31 counts in 40.1 seconds. And I'm going to carry on like this to every 0.3 until I get to the deepest spot in the centre there, which is about 0.9 meters deep. Then I'll start doing 0.2s and 0.8 measurements in the vertical. Okay, now I'm out in the middle of the channel where it's obviously a little bit faster. It's definitely a bit deeper. I'm up to 0.95 of a meter depth here. So because of the depth, I sort of have the suspicion that it may no longer be laminar flow, and measuring the 0.6 position may not give me the true mean velocity in this profile. So just to get a more accurate representation of the mean velocity at this depth, I'm going to do a 0.2 and a 0.8 measurement, and when doing the calculations, those two velocity measurements are averaged to give a more accurate mean velocity for this particular segment. To find our 0.2 position, because we're measuring from the bottom up, the 0.2 is going to be at the bottom. We multiply our depth by 0.2, our 0.8 position at the top, or just below the water surface, at 80% of the depth. Obviously you multiply by 0.8. So for example, say I've measured a meter depth, then it's quite simple to calculate that. Our 0.2 position would be at 20 centimeters deep, and our 0.8 position at the top would be 80 centimeters deep. So quite cunningly I've calculated that in my head, and 0.19 of a meter, and that's our 0.2 position down there. Pop it in position and push start, and obviously being at the bottom, it's closer to the bed, there's more friction, and we expect the velocity at that lower depth to be slower than our mean velocity, and certainly slower than the velocity we're observing at the surface. Okay, so that's our 0.2 measurement finished there. 31, 41.0, and then we'll stay in that same position of 4.5 meters across, and we're going to do another measurement on this segment at 80% of the depth. So at 0.95 deep, that's going to be 0.76 as our observation position of the meter. 6, 7. Yeah. That's our 0.8 depth there. And that'll be just below the surface. And start that. And you'll hear from the beeps that our velocity when measuring its surface is quite a bit faster than our last observation. There we go. And we've got 46 counts for 40 seconds. Okay, and so we're just going to carry on. We're going to keep the same vertical spacing here. We're going to carry on and do 0.3s until we get to a shallower depth on the other side, maybe around 0.7 deep. And then I'm going to complete the gauging doing 0.6s until I get to the far side of the bank. Okay, so I'm getting closer to the far side of the bank. I'm at 7 metres across now on my tag line. Back to 0.75 deep, so I'm going to change back from 2s and 8s. I'm going to start doing 0.6s again from this point onwards until I get across to the bank. So 0.75 deep, and I'm going to set it to a 0.6 measurement, which is 0.4 of our depth basically. And again, the simplest way to do it is to, for a 0.4 is to double it again, divide by 10. So 0.75 is 15, 30, so we want 0.3. And that's our 0.6 measurement, or 40% of the depth. And it's 37:40.0 seconds. So I'm back across to the far side now. The water's a little bit high today, so it's up above the normal edge of the riverbank. You can see there's the riverbed there, and then I hit the grassy bank, which is about there. So there's a bit of grass in the way. I won't be able to get my current meter in there because it'll be affected by the grass there. So I'm actually just going to call that a sounding, and because it's flowing, it'll be a sounding with a flow. So we'll give that a percentage assessment for that particular segment. So we'll measure the depth there, which is 0.1, and I'm going to give that about a 50% assessment for that segment, because it's about, looking at that, it's about half the flow that I can see on the surface. We'll call that a sounding in our gauging card and give it a 50% assessment value. So I'm right across to the water's edge, and that's 8.5 metres, and we're going to give that a water's edge of 0 depth. So that's written in my gauging card, 8.5, depth is 0, we're at the water's edge, right bank, and we'll give that a 50% assessment. And that's our gauging completed. So again, at the end of the gauging, I'm going to write down the time that we finished. So 11:05. And quite luckily I can see the staff gauge there, and I'll take an observation on the staff gauge again and wade safely back across and pack up my gauging. Take it back to the office, put it in some hot water and clean it, reassemble it and try it again.